Dear students, today I take this opportunity to discuss some more examples on vector algebra. So I am Dr. Shanmukh Kuchpal from Angadi College of Commerce and Science. So already basics, all these things we have discussed. So directly we will go for an example. Yes, so let us begin with the first example, today's first example. The 3 points whose point vectors are that given. So you can see here the vectors are given here. This is a first vector, second vector, and this is a third vector. Then we have to find whether they are equilateral triangle, it will represent, or right angle triangle, collinear or isosceles triangle. So for that, here we have to write a position vectors. So first one I represent it as a OA. OA is I plus 2j plus 3k. Second vector is, it is a OB. It is 3i 4j plus 7k. And third vector is OC. It is 3i minus 2j minus 5k. Further, we have to calculate the length of a AB. So the length of a AB we have to calculate. So the length of a AB is, it is a final value minus initial value. B is a second letter, final value minus initial value we have to take it. OB minus OA. So doing OB minus OA, that is subtracting OB from OA, we get it as 2i plus 2j plus 4k. Similarly, this is AB. Now we have to calculate BC length. It is final value OC minus OB. So OC minus OB is minus 6i minus 6j minus 12k. Similarly, CA we have to calculate. CA is, it is a OA minus OC. So OA minus OC, the simplification is 4i plus 4j plus 8k. So we observe that the vector CA is 2 times that of a vector AB. So one vector, it is a multiple of another vector, therefore it is a collinear. Option C is a right answer. So position vectors OA, OB, OC are given. So we have to calculate AB, BC and CA. One vector is a multiple of another one, so it means that it is a collinear. So like this we have to simplify. So let us do a second example. The position vector of the vertices of a triangle are, then it is which type of a triangle we have to calculate. So for that, given vector we represent it as a OA, OB and OC. So OA is 2i minus j plus k. OB is, it is a I minus 3j minus 5k. And OC is 3i minus 4j minus 4k. Then we have to calculate a AB. So AB is final value minus initial value and its magnitude. So already you know how to calculate a AB. Directly I will write a magnitude. Yes, from a previous example you know how to calculate the length OB, that is a final value minus initial value, OB minus OA. So directly I write a magnitude, it is a root 41. Similarly, the magnitude of BC is, it is under the square root of 6, and magnitude of CA is, it is root of 35. So it is a, we can see here that we can represent this as AB square equal to BC square. So bigger value is root 41. So I take a square of that. AB square equal to remaining two sides square, BC square plus CA square it is. So 41 equal to root 6 square is 6, root 35 square is 35. So we get 41 equal to 41. So it satisfies the Pythagoras theorem statement. Therefore it is a what, right angle triangle. Therefore option D is a right answer. Yes, yes, dear students, you can take a screenshot. So this is a first problem. You can take a screenshot of this, and this is a second example. You can take a screenshot of this. Okay, fine. Yes. So let us do the third example. It is given that the ratio in which the line segment joining the points 2, 4, 5, 3, 5, minus 4 is divided by the point. It is given. So it is a 2, 4, 5 it is, and next 3, 5, minus 4, and 0 to 23. So first point I take it as a, this is a B, this is a dividing a point P it is. So this is x1, y1, z1 I represent it. So this is x2, y2, z2 and point P is x, y, z. So line division we have a formula. So it is given by x minus x1 divided by x2 minus x. So already we know all these values, just we have to substitute. X is 0, x1 2, x2 it is a 3, and x is a 0. So if you simplify, we get minus 2 by 3 as an answer. So clearly we can see here that option B is a right answer. Yes, you can take a screenshot of this. Okay, so we'll move to our next example. Example number 4. The ratio in which the point whose PV means position vector is, it is a given, divides the joining the point whose position vectors are, two vectors are given. So for this, so first vector I take it as a. So like you can see here that one vector is A, so we take it as a C, vector C it is. Then 7i minus 2r I take it as a vector B, and this will be the vector A, and the related formula will write the ratio in which their position vectors are shared. So vector C equal to 1 into vector B plus vector R into vector A whole divided by 1 plus R it is. 1 plus R. So substitute C, vector A and vector B. R we need to calculate. Yes. So we get this as vector C is 1 plus 2j plus 3k. So 1 as it is we can simplify this one. So vector B is 7i minus k, vector R times vector A minus 2i plus 3j plus 5k it is. Whole divided by, it is 1 plus r. If you simplify this one, so collecting the coefficient of I, we get this as 1 equal to 7. 1 equal to 7 minus 2r divided by 1 plus r, and 2 equal to 3r divided by 1 plus r. Okay, if we simplify, we get solution for r is 2. Therefore, we have taken a ratio as 1 is to r, so we get a ratio as 1 is to 2 here. Therefore, clearly we observe that, so option B, 1 is to 2 is a right answer. So B is a right answer. You can take a screenshot of this. Yes. Next example, example number 5. The position vector of a point which divides the line segment joining the points. So this we take it as a vector A, and this was second one, we take it as a vector B, and the ratio is 2 is to 3, 2 is to 3. Then so we have to cross multiply in order to get it. So very simple, it is like this, is cross multiply it. So we get vector OP equal to cross multiply 2 is 2 into vector B, and we have to do 3 into vector A. So we get this as 12 plus 3 minus 4 plus 9 minus 8 minus 27 it is. So just we have to cross multiply, and whole divided by, we have to take a sum of the ratios, that is a 2 plus 3. Okay, so vector OP we get it as, so it is 1 by 5 of 15 comma 5 comma minus 35. This is simplification of a numerator. Now each term, this one we have to divide it by 5. So we get vector OP as 3 comma 1 comma minus 7. Therefore clearly it is option C is a right answer. Option C is a right answer. Like this way to calculate. Yes. So let us move to our next example. Vector A is I plus lambda j plus k. Vector B is given. Then it will satisfy that modulus relation. Mod of A plus B equal to mod A plus mod B. Then we have to calculate the value of a lambda. We have to calculate the value of a lambda. So I take a given expression, vector A plus vector B plus mod of vector A plus mod of a vector B. Then A and B are known to us. See, we have to calculate A and B. We have to calculate A plus B. So I plus, so they are collinear. We are going to get A plus lambda j plus k equal to P times I plus j plus k. This is a, so first one is a given. They are collinear, means it is a one vector is equal to, so some constant times another vector. So we get this simplification as equating I coefficient j and k, and we get p equal to 1 and lambda equal to 1 it is. So we want to calculate the lambda value. So option D is a right answer. Lambda equal to 1 is a right answer. Okay, we can take a screenshot of this. Yes, we'll move to our next example. Vector A and vector B are two non-zero and different vectors such that vector A plus vector B equal to vector B minus vector A. Then the angle between the vectors A and B is, we have to calculate the angle. So it is a very simple. So given expression is, it is a vector A plus vector B equal to B minus A it is. So we have to do a squaring on both the side. So A plus B whole square, it is A square plus B square, along with the vector it is plus 2AB, 2 into vector A dot vector B. And here also in the RHS we have to expand it. See, A square plus B square minus 2AB, 2 into vector B into vector A it is. So same quantity with the same sign, they get cancel each other. So it is a negative term. So we will transport it in a LHS. We get 2 times vector A dot vector B plus 2 times vector B times vector A equal to 0. Okay. So we get it as a 4 times vector A dot vector B equal to 0. So we get a dot product as a 0. Dot product as a 0 means two vectors are perpendicular to each other, then the angle between them is, it is a 90 degree pi by 2. Therefore clearly option C is a right answer. Okay, you can take a screenshot of this. Okay, we'll move to our next example. If A, B and C are 3 vectors and area of a parallelogram having diagonals A plus B and B plus C is, we have to calculate. So here area of a parallelogram is given by the expression. So here you have to remember, already in a theory you have studied this. So 1 by 2 magnitude of cross product of vector A and vector B. So 1 by 2 as it is, then vector A cross vector B. See, its cross product is, first row is ijk and second row is vector A ijk coefficients, right? So we have to calculate those using a position vectors. So OB, vector AB is OB minus OA, like that. So we get a 1 minus 3 2, and next one more we get it as minus 1 2 0. Okay, so if we expand this, we get this as 1 by 2 minus 4i minus 2j minus k, and magnitude we have to calculate. So magnitude of this is, so 4 square 16, then 2 square 4, then minus 1 square is 1. So we get it as root 21 divided by 2 square units it is. So clearly option B is the right answer. Yes. Okay, you can take a screenshot of this. Yes, we'll move to our next example. The question is, if vector A and vector B and vector C are given and A plus lambda B is perpendicular to vector C, then I am using a condition. Perpendicular means their dot product is 0. That is vector A plus lambda times vector B. See, it is a dot vector C equal to 0. Dot means their dot product is 0. Then we have to simplify this one. So substitute and simplify. 1 minus lambda times 3, 2 plus 2 lambda times 1 plus 3 plus lambda times 0 equal to 0. So if we simplify, we get a lambda value as a 5. If you simplify, no, you will get a lambda value as a 5. Therefore, clearly option A is a right answer. Option A is a right answer. Fine. Yes, everyone take a screenshot of this. Okay, fine. We'll move to our next example. The question is, if vector A and vector B are unit vectors and alpha is the angle between them, A plus B is a unit vector, then alpha we have to calculate. So here it is a given vector A plus vector B is a unit vector. So I find it this as vector A plus vector B. We take it as a 1. Then we have to square it on both the side. So we have to apply A plus B whole square formula. We get it as vector A square vector B square 2 times vector A dot vector B equal to 1. We get it. So these are a unit vectors. So unit vector means, so we get it as a 1 plus 1 plus 2 times vector A dot vector B equal to 1. So 1 get cancels. So it is a 2 times, it is a 1 plus 2 times cos alpha equal to 0. So if you simplify, we get a cos value as cos alpha equal to minus 1 divided by 2. Minus 1 by 2 means it is a 2 pi by 3. So this is the answer we are getting, the angle between them. So clearly option C is a right answer. Option C is a right answer. Like this we have to simplify. Okay, you can take a screenshot of this. Okay. Yes, we'll move to our next example. Here the vectors, 2 vectors are given, incline and an angle of, we have to calculate that angle. So incline and an angle means, so if you take their dot product, always it is greater than a 0. Then we have 2 vectors, their dot product we have to take it. So first vector is 2i mj plus 3mk, then dot vector B is, it is 1 plus m times I minus 2mj plus k, we take it as a greater than 0. It is dot product means, already you know, I coefficient is multiplied by I, so 2 into 1 plus m. J coefficient is multiplied by j, so we get 2m square. K coefficient is multiplied by k, we get 3m, so which is greater than 0. Okay, if we simplify this, it is a quadratic equation. Quadratic equation leads to a 2 solution, so we get m is less than minus 2 or it is minus half. Therefore option D is a right answer. So like this we have to solve it. Okay, yes, so you can take a screenshot of this. Yes, we'll move to our next example. If n1 and n2 are 2 unit vectors, theta is the angle between them, then we have to calculate the cos theta. So for that I am taking n1 plus n2 whole square equal to, it is a square plus b square plus 2 ab, like this it is. Then unit vectors those are, so we have to take it as 1 plus 1 plus 2 times n1 n2. This dot product we have to take it as a cos theta. So 2 plus 2, it is a angle, it is cos theta. So we have to take 2 as a common, we get 1 plus, it is a cos theta it is. Then it is a 2 as it is, we have to write it using a half angle formula. So it is a 2 times cos square theta by 2. So this is n1 plus n2 square. So clearly, so solution for cos theta by 2 is, it is yes 1 by 2 n1 plus n2 square. So it is a very clear. Okay, so option A is a right answer. So we'll find option A is a right answer. Like this we have to solve. You can take a screenshot of this. Okay, so we'll move to a next example. Vector A, vector B are given, then the vector C for which A, B, C forms right-handed system is. So here we can write this as vector C equal to A cross B it is, and we know the vector A, it is xi plus yj plus zk cross vector B, it is a j. So cross product will be, we get xk minus zi, we are going to get it. So xk minus zi, clearly option B is a right answer. So you can take a screenshot of this. Okay, we'll move to a next example. Yes, 14th. So u, v, w are the three vectors non-coplanar, means they are not lying on a same plane. Then what is the value of this dot scalar triple product? We have to calculate. So I am taking that expression, I am simplifying u plus v minus w. Okay, inside it is a dot, outside it is, so we have to simplify it. U cross v minus u cross w minus v cross v minus into minus plus v cross w here, like this. And you know, in a cross product, say two rows are identical, the value will be become a 0, so this will become a 0. Yes, so yeah, so further simplifying, we get this as u dot v cross w, we are going to get it. Yes, so here further I write u dot v dot w, we get it, so which is going to be a 0. Therefore option A is a right answer here. Yes, we are going to get this as an answer. Yes, you can take a screenshot of this. We'll move to our next example. Yes, so this is an example, like they are given an expression. So this is a vector and another vector, we have two vectors a right angle to each other, then the value of a p is. So right angle means, so first vector I take it as a A, second vector I take it as a B, and right angle means their dot product is always equal to 0. So dot product we know, so dot product is I coefficient is multiplied by I, j coefficient is multiplied by j, and k coefficient is multiplied by k. So we get this is 3 times 1 minus p plus 2 times 1 plus p equal to 0. If we simplify this, we get a p value, we get it as a 5. Therefore clearly option D is a right answer. So like this we have to solve it. You can take a screenshot of this. So in this class we have studied about using basic properties, how to simplify the example. So this is about the vector algebra. So in the next session, so we'll continue the concept, Yes, I hope you are all watching this video. Thank you for watching this video once again. Thank you.